While some scientists did not accept this idea at first, supporting evidence continued to accumulate, including the discovery that theropods had a feature of birds not previously found: a wishbone.
People had sort of looked for them and really didn't know what it was going to look like. And then all of a sudden, we started finding them. Here is the wishbone of Tyrannosaurus rex.
When scientists analyzed the skeletons of theropods in birds, they found too many similarities for any explanation but common ancestry. Jack's collection at the Museum of the Rockies offers an opportunity to compare their features.
Here's an Albertosaur tibia. As you can see, it's hollow, just like a modern bird.
This is a T-Rex foot. What we see here are 3 forward-facing digits that bear the weight of the animal, and in the back, a much smaller digit. If we take a look at this chicken foot, we'll see the same pattern. We've got 3 forward-facing digits, and on the back, a much smaller one. All dinosaurs share an S-shaped neck. You can see it here and in living birds like this chicken.
New kinds of evidence also emerged. In 1978, Jack made the surprising discovery of a vast dinosaur nesting ground.
We discovered that dinosaurs nested in colonies and cared for their young, brought food to their babies. We also had evidence that they came back probably over and over again for many years to the same site.
In a radical shift, by the 1980s, a consensus was finally building that birds descended from theropod dinosaurs, from active predators that walked on 2 legs. But scientists were about to discover the most startling evidence of all. In the mid-1990s, farmers in northeast China began unearthing dinosaurs 120 million years old. And these fossils preserved astonishing detail.
In 1996, I was a first-year graduate student at my first scientific meeting. They were passing around pictures of this dinosaur.
This chicken-sized theropod, named Sinosauropteryx, did not have scales. It was covered in some primitive kind of feather.
To see those photos of a tiny, fuzzy dinosaur, it just blew everybody's minds.
This dinosaur was just the first of many fuzzy and feathered theropods to be uncovered. Another, called Caudipteryx, had feathers identical to living birds on its tail and hands, but lacked wings. With the discovery of these spectacular feathered finds, there was no longer any doubt that birds were related to theropods. But while feathered dinosaurs settled one question, they raised a new one. These animals could not fly. Why were they feathered?
It was long assumed that feathers evolved for flight. But what we found was that clearly feathers predate flight and arose for some other purpose.
So why did the first feathers evolve? That's hard to tell from just the fossil evidence. But living birds may offer answers. Feathers provide insulation, so the first feathers might have helped keep dinosaurs warm. Birds also use colorful feathers in communication, in courtship, and in territorial displays. dinosaurs may have used feathers in the same way. Feathers likely played different roles at first, and then were modified for flight. The modification of an existing structure for a new use is called co-option. It is a common way that new structures and abilities evolve. Bird wings are modified forelimbs, once used for grabbing and feeding. Just as the walking limbs of land animals are modified fins. And the turtle shell is a modified rib cage. So the co-option of feathers for flight enabled Archaeopteryx and its relatives to take to the air. And other features also evolved.
When we look at evolution after the origin of flight, we see a lot of characteristics of living birds gradually accruing.
But not in a simple linear sequence. Like other dinosaurs, this crow-sized bird had large claws on its hand. But like living birds, it had a toothless beak and a short, bony tail. While this species had teeth, its hand bones were partially fused to form a stronger wing. And this bird had a large breastbone for well-developed flight muscles like living birds. But it also had teeth.
We don't find forms that are somehow lockstep intermediate between Archaeopteryx and living birds. But we find a diversity of forms we could not have predicted.
For tens of millions of years, an assortment of scaly dinosaurs, feathered dinosaurs, and many types of birds lived together. Then, 66 million years ago, almost all of these creatures died out. A 6-mile-wide asteroid slammed into the planet and triggered a global mass extinction. Only a small group of toothless birds survived. And they evolved into the 10,000 species of birds we see today. We once might have said that the dinosaurs all died out. But now we know that living birds are a lineage of theropod dinosaurs in the same way that we are a lineage of primates.
Have dinosaurs gone extinct? Absolutely not. We separate dinosaurs into two groups now. The non-avian dinosaurs, fortunately, have gone extinct. And the avian dinosaurs are still alive, making it a beautiful world.
Dinosaurs are still with us. We just call them birds.